Good morning, good afternoon, good evening, depending on where you are watching me from. Welcome to Tutorial with Mr. Abraham. Today, I'll be teaching on a topic called hybridization. Hybridization. Now, what is hybridization? Hybridization is the mixing or blending or the union of two or more orbitals to form a new hybrid orbitals. You can see from the board. This is the mixing of atomic orbitals to form a new hybrid orbitals. Or you can say the union of two or more orbitals, or the blending of two or more orbitals. Now, what are orbitals? Orbitals are regions in the nucleus where electrons can be found. I repeat, orbitals are regions in the nucleus where electrons can be found. We have several types of orbitals. We have the S, we have the P, we have the D, and we have the F. Now, let me explain what each of these orbitals stands for. The S is called sharp. The P is called principal. The D is called diffuse, while the F is called fundamental. So, for every JAMB student, every white or NECO student, even the nursing student, you have to know the meaning of each of these orbitals. Like I said, S means sharp, P means principal, D means diffuse, and F means fundamental. Now let's go. We said this is the mixing of atomic orbitals to form a new hybrid. Now, like I said before, I said we have S, P, D, F. Now we said the mixing. When S combines with P, it forms sp. So this one is the mixing of S and P orbitals, and this is the hybrid. Like we said before, the mixing of two or more orbitals is called hybridization. So this is the hybrid. So we have the hybrid here. So when S and P mix together, they form sp hybrid. Then we also have S plus P plus P. In this case, we have one S combined with 2P. It forms sp². So this sp² is the hybrid. Now we have S plus P plus P plus P. One S orbital combines with 3 P orbitals to form sp³. So this is the hybrid. So just like we said hybridization is the mixing or blending of two or more orbitals. So this one is the mixing or the blending to form a hybrid. Is that clear? So these are the hybrids. We have the sp, we have the sp², we have the sp³, we have the sp³d, we have the sp³d², we have the sp³d². It goes on like that. So these are your hybrids, and this is the mixing. So like I said hybridization is the mixing of atomic orbitals to form a new hybrid orbitals. What are orbitals? A region in the nucleus where electrons can be found. And we have different types of orbitals: the S, the P, the D, and the F. Thank you. All right, I have some few examples here to do. We have some few examples here. So let's determine the hybrid of these molecules. We have the SF6, the sulfur hexafluoride. We have the carbon dioxide or carbon 4 oxide, and we have the ammonia. So let's look for the hybrid of these molecules. Now, if you want to look for the hybrid, you must pass through 2 steps, easy step, because you have to look for the lone pairs. I did a video on lone pairs. Please go to my YouTube channel and watch the video of lone pairs. Lone pairs are electrons that do not take part in chemical bonding. Now, lone pairs equals to group number of central atom minus valence atom. Minus valence atom. And also, to look for the hybrid, we have the lone pair plus valence atom. Exactly. Now, in this case, now let's do the first one. We have SF6. Now, what is a central atom? A central atom is an atom in which all other elements are connected to. And how do you know a central atom? A central atom always starts a compound. Please, this must be noted. Is that clear? A central atom always starts a compound, except hydrogen. Please, in the case of water, hydrogen is never a central atom. Please take note. Take note. I know that said central atom always element that starts at elements are called central atom. Is that clear? But in case of water, hydrogen can never be a central atom. Please, that must be noted. So to solve this now, we have S as a central atom, which is sulfur. So to solve this, to look for the low pair first, we said group number of central atom. Now, which group is sulfur? Sulfur belongs to group 6 in the periodic table. I'm going to do a video on how for you to predict an element in the periodic table. So sulfur belongs to group 6 of the word periodic table. So we now say the group number of central atom is 6 minus valence atom. What is the valence atom here? Fluorine. Fluorine has a valency of 1. 1 times 6 is 6. We have 6 all over 2. Now, 6 minus 6 will give me 0 all over 2. Now, when you divide 0 by 2, it gives you 0. So, this compound here has a 0 lone pair of electron. Now, to get the hybrid of this particular compound, so we have hybrid equals to, what is the lone pair? Lone pair is 0. So, we have 0 plus, what is the valence atom? Valence atom, we have the valency of 1. 1 times 6 is 6. So we have 6. So the hybrid is H equals to 0 plus 6 is 6. Then we'll come, we trace, look for 6 here. So you can see. So the hybrid of this compound is sp³d². So the hybrid of this sulfur hexafluoride is sp³d². That is the hybrid. Now let's go for carbon. Carbon is the central atom, like I said before. So elements that starts a compound are called central atom. Most of them are always central atom. So what group is carbon? Carbon belongs to group 4 in the periodic table. So we say 4 minus valency of oxygen is 2. 2 times 2 is 4 all over 2. 4 minus 4 is 0 all over 2. Now when 0 divides 2, we have what? 0. So carbon 4 oxide have 0 lone pair. Now, how do we find the hybrid of carbon 4 oxide? Hybrid is lone pair plus valence atom. Lone pair is 0 plus valency of oxygen is 2. 2 times 2 is 4. So we have 4. Now, hybrid equals to 0 plus 4 is 4. Then you trace. Look at 4 here. So we have sp³. So the hybrid of this compound is sp³. I hope you are following me. Now let's do the last one. Now nitrogen is the center atom. And what group is nitrogen? Group 5. So we have 5 minus, what is the valency of hydrogen? 1. 1 times 3 is 3. So we have 3 divided by 2. 5 minus 3 is 2 all over 2. Now when 2 divide 2, we are having what? 1. Then we come to look for the what? The hybrid. Formula for hybrid is what? Lone pair plus valence atom. So the hybrid equals to, what is the lone pair? 1 plus, what is the valency atom? Valence of hydrogen is 1 times 3 is 3. So we have 3. Now hybrid equals to 1 plus 3 is 4. Then you trace 4. Look at it. So ammonia belongs to what? sp³ hybrid orbitals. So ammonia belongs to what? sp³ orbitals. So I hope you are following me. So this is how to look for what? The hybrid. Then let me give an assignment. Do this one and submit on the comments below, please. Do this assignment and submit it in the comment section below. So look for the hybrid of CH4 methane. Please look for the hybrid of CH4 methane. Do it and submit it in the comment section below. Thank you and have a nice day. God bless you.